Hey everyone, buckle up because we're diving into some seriously mind-blowing stuff today.
Oh yeah, this is gonna be good.
Quantum computer.
Willow.
Willow, right. And its potential link to parallel universes. Yeah, you heard that right. We're not just talking faster computers here.
Not even close.
We're talking about concepts that could completely change how we see reality itself.
It's pretty amazing how this one discovery has gotten everyone talking, bringing together the latest science with these ancient ideas about the cosmos.
For sure. Willow has captured people's imagination. It's not every day a tech breakthrough makes you question the nature of reality.
Exactly.
So let's break down what makes this Willow chip so special.
Well, for starters, Willow has 105 qubits.
Okay, and that's a lot.
It's a quantum leap, pun intended.
Of course.
It's smashed speed records. It's showcasing what we call quantum supremacy. But to really understand how big this is, we got to understand how quantum computing is different from the computers we use every day.
Okay, yeah. So our everyday computers use bits, which are either 0 or 1. But quantum computers use these things called qubits, right?
Exactly. Qubits are where things get really interesting. They tap into the weird world of quantum mechanics, specifically superposition and entanglement. Imagine a qubit being both 0 and 1 at the same time.
At the same time? What?
Yeah, that's superposition. It's like it's in multiple states at once, which opens up a whole new dimension of possibilities.
Whoa, okay. And entanglement. Is that where two qubits are connected somehow, even if they're miles apart?
That's it. They have this invisible link. So if you change one qubit, the other one changes instantly, no matter how far apart they are.
No way. That's insane. It's like they're communicating faster than the speed of light.
It's wild, right?
So how did Willow prove its quantum supremacy? What did it actually do?
So picture this. They gave Willow a task. It's called a random distribution benchmark. Sounds complicated, but basically it had to analyze and create patterns based on these incredibly complex quantum events. This kind of problem would take the fastest supercomputer on Earth a mind-boggling amount of time to solve. We're talking like 10 septillion years.
That's 10 septillion.
That's a 10 with 24 zeros after it.
Okay, that is just unimaginable.
And get this, Willow did it in under 5 minutes.
Seriously?
Yeah. It's not just about speed, though. It's about showing that quantum computers can solve problems that are basically impossible for regular computers. That's what quantum supremacy really means.
It reminds me of that claim Google made back in 2019 about achieving quantum supremacy. Some scientists were skeptical back then, right?
They were. Some folks argued that, maybe regular computers could eventually solve those problems, just way, way slower.
Yeah.
But Willow's accomplishment, exponentially more powerful. Each qubit you add doubles a quantum computer's power. So with 105 qubits, Willow is in a whole other league.
So it's not even a competition anymore. I also read that Willow uses something called error correction.
Oh yeah, that's a big one.
That seems like a pretty important thing in the quantum world, right?
Absolutely. Quantum systems are super sensitive. Even the tiniest change in temperature or vibration can mess up the calculations. Error correction is like a safety net. It's constantly checking for and fixing those errors, making quantum computing more reliable.
So it's like a spell checker for quantum computers.
Basically.
Okay, so Willow is this ridiculously powerful machine doing things we thought were impossible. But here's where things start to get really trippy for me. The whole parallel universes idea. Are scientists actually saying that Willow might be tacking into other realities?
Yeah, it's creating quite the buzz. See, quantum mechanics is full of mysteries. One of the biggest is what happens when we observe a quantum system. Remember how a qubit can exist in multiple states at once?
Yeah, like it can't make up its mind.
Right, but when we try to measure it, it collapses into a single state. It's like it has to choose.
Like it suddenly has to pick a side and stick with it.
Exactly. That's the common way of thinking about it. But physicist David Deutsch, he proposed a different take on it.
First, it is the idea that the physical world that we see around us, the room, the stars, galaxies, and so on, is just one tiny sliver of the whole of reality. And the whole of reality includes many such objects, many of the kinds of objects that we have traditionally thought of as the universe. And so it's sometimes called the many universes theory. I actually prefer I prefer to call it the multiverse theory because it contains a lot more than just those things that we used to call universes. It contains other structure as well. So the whole thing as a whole, reality as a whole, is the multiverse.
Just one reality, there could be countless realities playing out at the same time, with all these different versions of ourselves making different choices.
You got it. And here's where it gets crazy. Could Willow's speed be because it's accessing calculations happening in parallel universes? It's like imagining billions of Willows working together across these different universes, all crunching numbers, and the final answer pops up in our reality.
That's a lot to take in. But you mentioned that the mainstream view doesn't need multiple universes, right?
Right. The Copenhagen interpretation suggests that those multiple states are just probabilities. When we measure a quantum system, it's like rolling a dice. One outcome wins, the others vanish. No need for parallel universes.
So we have this groundbreaking tech with Willow, and it's making us rethink the very fabric of reality. It's like science fiction is merging with real science.
And it's not just modern science grappling with these ideas. You know, it explored how ancient Hindu cosmology also features the concept of a multiverse.
Yes, the one about Krishna, an avatar of the supreme being in Hinduism, revealing the existence of countless universes. It's amazing to see those connections.
It really is. In the Bhagavad Purana, which is a Hindu text, Krishna shows Brahma, the creator god, that our universe is just one of many floating like bubbles in this massive cosmic ocean.
I remember that. And then there's that whole concept of Brahma's day and night, each lasting billions of years.
Each day and night cycle for Brahma represents the creation, destruction of universes. It's this cyclical view of existence. The universe is constantly being born and dissolving back into this cosmic ocean. And it's all beautifully depicted in ancient Hindu art, with universes as bubbles.
It's mind-blowing to think that these concepts, explored by ancient cultures, are finding a place in modern physics. It really shows how humanity has always tried to understand the universe. Willow is proof of parallel universes, right?
Of course not. Skepticism is a healthy part of science. Physicist Sabine Hossenfelder, for instance, acknowledges that Willow is impressive, but argues that the problem it solved doesn't have real-world applications yet. It's a proof of concept, not a revolution in itself.
So while it's impressive, it's not quite ready to change the world.
Not just yet. There are still hurdles to overcome, like scaling these quantum computers up.
Yeah.
Willow has 105 qubits. We might need millions for truly practical uses and even better error correction.
So it's still early days, but it feels like we're on the edge of something truly groundbreaking. It's exciting and a little scary, you know?
I totally agree. It's like standing at the edge of the unknown. The potential benefits are huge.
Yeah.
Imagine changing medicine, materials science, cryptography. But we have to move carefully. Think about the ethical implications as we unlock this powerful new technology.
That's a really good point. So much to consider here. We've only just scratched the surface of this topic, into these parallel universes, and then we talked about ancient Hindu texts with universes as bubbles in a cosmic ocean. It's kind of poetic, isn't it?
It is. It's fascinating how these ancient cosmological ideas, from philosophy and spirituality, are now being echoed in cutting-edge science. It really shows how human curiosity and that desire to understand our place in the universe has always been there.
For sure. But let's get back to Willow for a sec. We talked about its potential, but also the challenges in actually making these quantum computers bigger and better. What are some of the biggest roadblocks scientists are facing right now?
Well, one of the main challenges is keeping these quantum systems stable. Qubits are incredibly sensitive. Even the tiniest change in the environment, like a little temperature change or a vibration, can mess up their calculations.
Really? That sensitive?
Oh yeah, it's like trying to build a house of cards in a windstorm.
So how do scientists deal with that kind of sensitivity?
It takes a multi-pronged approach. They're developing some really sophisticated error correction techniques. There are algorithms that can find and correct errors in real time.
So like a super advanced spell checker that's always running.
Exactly. Constantly checking the quantum computations, making sure everything's accurate. And they're also building these computers in super controlled environments, like shielding them from any kind of interference.
Wow. So it sounds like it takes incredible ingenuity and precision to make these systems work right, even for a little bit.
Absolutely. But the potential benefits are enormous. Just imagine designing new drugs with pinpoint accuracy, developing materials with crazy properties we've never seen before, or creating encryption that's unbreakable, protecting all our important data.
Those are some serious game changers. Let's dive into those potential applications a bit more. You mentioned drug discovery. How could quantum computers revolutionize that whole field?
Well, right now, developing new drugs is a long and expensive process. Lots of trial and error, testing tons of molecules. Quantum computers can change that. They can simulate how molecules interact in a really complex way.
So instead of taking years to develop new drugs, we could potentially do it way faster.
That's the idea. Quantum computers can help us identify which drug candidates are worth pursuing much faster and much more accurately. And it's not just speed, it's precision too. This could lead to better treatments with fewer side effects.
That would be incredible. What about materials materials science? What kind of breakthroughs could we see there?
Imagine being able to design materials that we can only dream of now. Super strong, but ultra lightweight for things like spacecraft. Or materials that can capture and store solar energy super efficiently, changing how we power the world.
Wow. We're talking about materials that could help solve climate change, resource scarcity. It's like science fiction coming to life.
It really is. Of course, we're still in the early stages, but the potential is huge. And then there's cryptography, which is all about keeping information safe and secure.
Right. And with all the cyber attacks and data breaches happening these days, that seems more important than ever.
It is. The encryption we use today relies on math problems that are hard for regular computers to crack, but quantum computers could potentially break through those codes easily.
So our current cybersecurity could become useless. That's kind of scary.
It's a real concern, but researchers are already working on new encryption methods that can withstand quantum attacks. It's like a technological arms race, constantly pushing the limits of what's possible.
It's fascinating and a little intimidating to think about all the implications. Like, we're on the edge of unlocking a whole new level of tech, but we have to be really careful about how we use it.
I couldn't agree more. Like with any powerful technology, we have to think about the ethics, make sure it benefits humanity, not harms it.
Right, that's a crucial point.
Yeah.
So how do we handle this uncharted territory? How do we make sure we're using this power responsibly? It feels like we're walking into the unknown, both scientifically and ethically.
I think it starts with open and honest conversation. Scientists, ethicists, policymakers, everyone needs to come together to discuss these issues, develop guidelines for responsible development. It's not just about the science. It's about our values, our priorities. What kind of future do we want?
It feels like we're at a crossroads, and the choices we make now are really important for the future. It's exciting and scary all at the same time.
Definitely a pivotal moment in history. We need to think about the long-term consequences, not just the immediate benefits. Curiosity and caution, that's the key to navigating this new frontier.
I hear you. Throughout this whole deep, been feeling this mix of wonder and worry. Wonder at all these incredible discoveries, but worry about the challenges that come with them. It's a lot to think about.
That's a totally understandable reaction. Those complex emotions are important. They remind us that we're dealing with some really big questions that don't have easy answers. It's okay to feel both excited and unsure as we step into this new era.
So where do we go from here? What can we do as individuals to really understand these ideas and help create a better future? It feels like we're on the verge of something huge, but it's hard to know what our role should be.
I think the most important thing is to stay informed, stay curious, and keep asking questions. Don't be afraid to dig into these topics, explore different viewpoints, and have those tough conversations. The future of quantum computing? Heck, the future of humanity depends on us being wise and willing to wrestle with these complex issues. What we do, the choices we make, even our voices, they all matter in shaping that future.
That's a powerful message. As we move towards the end of this deep dive, I want to leave you all with a thought that's been sticking with me. It's from Niels Bohr, one of the pioneers of quantum mechanics. He said, "Everything we call real is made of things that cannot be regarded as real."
Whoa, that's deep.
This is how quantum computers could reshape our world, those massive timescales. But what does it all mean? How does all this change how we see ourselves in this crazy universe?
That's where it gets really interesting. I mean, philosophers have been thinking about existence, consciousness, free will for centuries. And now, with all these scientific advances, it's like those questions have taken on a whole new meaning.
Right. If there really are multiple universes, countless versions of ourselves out there living different lives, what does that even mean for our choices, our sense of self? Do our actions even matter if every single possibility is playing out somewhere else?
It's a wild thought, isn't it? It makes you question everything. Maybe our choices matter less if every outcome already exists in some other universe. Or maybe it's empowering, knowing that there are infinite versions of us out there trying every single path. Philosophers, the people making...
Feels like we're at a turning point, and the choices we make now will have huge consequences.
We're going to come across more questions than answers, and that's okay.
The journey is just as important as the destination, right? And who knows what mind-blowing discoveries are waiting for us as we push the boundaries of what we know.
That's the amazing thing about science. The universe is full of surprises. Every discovery changes how we see ourselves and the cosmos. It's a never-ending adventure.
It truly is. Well, that's all the time we have for today. Thanks for joining us on this wild ride into the world of quantum computing, the multiverse, and all the big questions they raise. We hope it sparked your curiosity and left you wanting more.
Keep exploring, everyone. Remember, the universe is full of possibility.
Until next time, keep questioning, keep learning, and keep wondering.